Okay, so I'm back here. So last video we converted a lot of our stuff over to use a block pause object instead of using a location object. Um, this did not get the result we wanted. We pretty much ended up with the same problem as before, where when we fire off explosives, they're not pathing to their full size. This is only giving us a path distance of pretty much 3 out from the center, where this explosive, this exact one, should do 26. So it should have a really large radius. Actually, I think it does 13 in both directions and 26 is the diameter. But it's having a lot of difficulty pathing quite a bit, and it's just flat out not wanting to operate the way it's supposed to. This is not just this explosive, it seems to be affecting all explosives, and it was happening even before we switched over to block pause. For this video, we're going to keep investigating what's wrong with our system. After all, this is a pretty crippling blow to the blast code, so it has to be fixed. The way we're going to do this is we're actually going to start setting up JUnit tests. And luckily for us, this system is designed to be tested one run at a time. So we can go, okay, I want you to run only one which will be, it'll go to 1 and it'll stop running. And that way we can sit there and slowly watch the Pathfinder as it runs through its system. And we can go, okay, why didn't you detect these blocks this run? Because you should have detected those blocks that run. There's a few other things we can do. If the JUnit test doesn't work to handle it, the next option is we can visually track it by saying, okay, I want you to place smoke at that location for a couple ticks and then just kind of work your way around. And that way we can watch it very slowly map over a distance. But the JUnit test is going to be the best option right now because we can leave it in here where we can't leave the other one in there to work. So let's see, we want to prefabs blast. We already have a test for this. So let's go ahead and run the test real quick and see what happens. It's probably going to fail. No such method exception. Derp, that's problematic. It thinks it passed though, unfortunately. I can fix this though. This is part of the super method, and luckily it's in here, and we just can go if Minecraft forge dot there should be a way to tell if forge is even loaded. Luckily it's not too big of an issue. Actually, no, there's another way we can do this. If engine.is JUnit testing, we can basically say, okay, if we're JUnit testing, don't register the bus. Because remember, we added a fix down here for world unload to prevent issues with when the world actually exited out, that these blasts did not continue to run. But that's not what we want to test. Okay, so according to this, it ran, even though I don't really trust it to have run all the way through. Because we only got to see one event pop off. Yeah, it's like test blast ran, but is that the only thing in here? Yeah, that's surprisingly the only thing in here. And it's confirming that it's running the proper size. That's weird. Yeah, because we look over this, and we're checking our blast. So we're popping off at 0, 30, 0 of 1 and 7. So we're checking blast. Check values. Assert same. So So we're expecting 7 blocks pretty much is what this actually is. It's actually labeled wrong. So it's basically saying, okay, my edits need to be this size, so it needs to say I've edited like 7 blocks. And then I needed to have done a whole bunch of stuff. It's actually that means this should have run properly. There's definitely something weird going on, because if this says it's run at the right dimensions, and yet we're looking over here and we're going, okay, that's not running at all. And I need to turn the rain off. I need to make sure I get my anti-rain mod added back to this instance. So we fire this, and it's just not behaving as expected. It's not pathing down, it's not doing a lot of the things it's supposed to be doing right now. This pretty much sets anything to gold, by the way. Pretty much one of the Midas touch type of system. Very strange, though. I mean, this blast we're testing, of course, isn't threaded, so maybe it's the threaded system that we're. That doesn't make sense either, because the thread shouldn't be causing problems like this, because after all, the only thing it does is just run calculations outside the main thread. We're clearly getting a size problem here, so maybe it's the size check that's failing. Because right here, we don't exactly have a size check thing in here. At least not in this main part. Actually, no, we should have one. Should path to. Should path contains. This is location check. Is less than size. So let's put a debug line here. I probably should have thought that one through a little bit more. Doing this, we can see what blocks it's passing. If I'm not mistaken, it's passing a couple of the same blocks a few times here. That may be the issue. Okay, so double distance equals do distance. Reload that. I'm going to restart this, and I'm going to add a really sophisticated debugger to this real quick. That way I can see exactly what this thing's doing. If I can remember what the debugger is even called. I think it is called Debug Helper. No. JSON block processor. The JSON block processor has this in it. At least it should. It's a debug printer. Basically, we want to get one of these real quick because this will give us more detailed info on what the thing's doing. It unfortunately will mean I have to kind of read through this a little bit more carefully. But it should work. I'm just going to do I gotta make sure I'm doing them down here. Debug printer equals new debug printer. And then what does it need argument-wise? It needs a logger, so we're just going to steal the engine's logger. Logger was null, okay. And then I'll set this in both spots here. And then what we're going to do is we can call debugprinter.start get affected blocks. And then I can do debug end down here. And then what we want to do is we kind of just want to nest our debugger as it runs. So for starters, we want to make sure we print out whatever center is. And we don't want to do start here, we want to do, I believe, message. It's just log. Center this, and then plus center. And this would be path entire. And this will actually be a start section. So this would be .start. And then all the way at the bottom, right before we do any returns or anything, we would just go debug printer.end. And then what we want to do here is we kind of want to just input what data we have so we can see what's going on. So we got, that's not what I wanted to do. I don't know how my cursor got down there. So there's that. List.size. And then count. I know there's a way to set enabled and disabled in here. And this would be engine.running as dev. This way I can leave this in here and I don't have to worry about it actually spamming chat with debug messages. It'll turn itself off if we're outside the dev environment. We'll add a few other variables to this here later, like being able to enable and disable it whenever we want to. But now the next section is we want to kind of debug every time we go into the new thing here. So you want to go start, and this would be some kind of entry. I'm just going to call it L. And we'll end it at the bottom here. What this will do is this will nest it so it's really, really easy to read. What we can actually probably do with this as well is put current count here. That way we can differentiate the lines a lot quicker. And then we'll do things like this. We'll get our connected sides here. And we don't want to do a start here, we want to do a log. You know what, we'll start a section here just because it'll be slightly easier to debug information about the section. We just have to make sure we end it down here. And we'll go okay. Should path 2. Or this will be applied edit is actually what that'll be. And then we can just go ahead and start this up. And this will give us a nice debug path real quick. And then, I mean, about the only thing we can really do, because we look at this and this is running, which is telling me that it is giving me the correct scale. At least it should be, because I mean, it's giving me pretty much what I'm looking for. Unless there's some duplicates in here. It's actually to do look for duplications. Because we could be getting 30 edits out of this list, but we could be getting 30 duplications. That's something that actually this doesn't do. Trying to think of like the best way to look for a duplication, actually. Actually, I know a way to do it. It's really dumb. It's an O2 operation. How it pretty much works is you'll do a for loop just like above, except you'll do another for loop as well. So you loop through all the entries, and what you want is if edit doesn't equal edit 2, because you don't want the exact instance, but then you want to go, okay, if edit dot equals edit 2, and then you want to go fail. Edit values contain duplication. Actually, we want to be more specific with this line. We want to go if xi equals edit 2 dot xi, and we're going to do, no, we could do it that way. That'll work. This is where I always say we need more JUnit testing. This is an example of why, is we got to do things like this. Okay. And then we want to just kind of run it. That was weird. We got no debug on that, even though the debug runner should have been running. Probably because the debug was null. Speaking of which, we didn't actually launch Minecraft. Yeah, I'll launch ICBM only. So there's no duplications, so that's not a problem. The only thing now is if we want to keep going with the JUnit side, is we gotta write really elaborate JUnit tests. And I honestly mean elaborate. Yeah, I'll start writing this while we wait for the game to run. Is what it would be is I need to pretty much copy this, put this down here. This would be test blast exact. And I want to create a blast. Of course, I want to set its location as well, make sure it actually has everything it needs. We're going to, yeah, we'll trigger it at pretty much the same place we're triggered everything else at. We'll set its size to set to 3. You know why this is probably we're not getting what we're looking for is because the smaller blasts actually are running perfectly fine. It might be the bigger blasts that are not running. The problem is I'm not exactly sure how many blocks a bigger blast should edit because I don't have an equation to mathematically get that appropriately. I have some equations that are supposed to work, but not perfectly. But we'll start with this because we know this is going to produce 123 blocks. It's a really good place to start. So when we run this the first time, so if we go blast dot get affected blocks. Actually, I need to go down here and look at the super here. What I want to test is path entire actually. So I'm actually going to come up here and I'm going to change the name of this. Test blast path entire, because it's the pathfinder we want to kind of work on. And what I want to call is I want to call that, and then I need a list of blocks, a node to start with, so whatever our starting node is. Where's this even called from? Get affected blocks. Is it pathing from the center every single time? That might be the problem, is it's not remembering where its pathfinder was at. I'll work on this in a second. Let's just really quickly, I want to test to see if the debugger's running. Okay, the debugger's running, but it's spitting out a lot of junk. Actually, it's just... Oh no, it's running. There's our debugger. I think we forgot to call an in-call somewhere around here, because it just keeps going and going and going. Yeah, we're missing an in-call here. Okay. Debugger start, we should have an in-call at the end of this loop here. We have an in-call there. Should have a start at the top of this somewhere. Yep, we do. Okay. We should have a start at the top of this. We do. Oh, here's where our problem is. These should be log calls. Derp. Yeah, if you don't call end on it, it won't end in back. And then comment this out real quick so I won't error on me. Okay, let's see if it properly debugged this time. We're not getting anything now. Probably because, yeah, it's just all the way over here. Yeah. This is what our debug at least looks like, though. It'll tell us where we're at, it'll tell us what location we're pathing each time. It looks okay, I guess. We just kind of have to restart this real quick. So that's not at least getting us anywhere. Okay, let's take a look at the simple thing, processor, whatever. Because I think I realized what might be wrong with this. It's going to call get blocks every single time. I think. Yeah, let's take a look at the Pathfinder system. Maybe not doing what I think it's doing. Layered action should continue. Okay. Okay, it's just going to call get affected blocks every single time. Collection. I think what's happening is it's not resuming from its last spot properly. Because is if it is indeed calling get affected blocks every single time. That means we're recalculating the center every single time. Which then means we're recalling to path next every single time. Which is then going to be called, well, actually we're calling path entire, which is then going to give us everything we wanted, which is then going to pass in the starting node again, which is going to go, okay, should path, which is going to say no because we've already pathed it, we've already been there. Well, that doesn't make sense why we're... There's some system in here that knows how to run properly. Because it is working, just not working correctly. So if we call this, it's just a distance check right now. I think what I need to do is I need to make some kind of method in here that will call get affected blocks and will say you've already started pathing, resume where you were at. So we're going to make a method for this. So we'll call get affected blocks and we'll go, okay, int layer. Actually, I'm going to implement this on the super, but I'm going to go ahead and put it in here just so I can cut it out real quick. And then that way we can dump it right here. And what we want to do is we're going to go, okay, if layer equals 0, we want to call the get affected blocks normally. And then if not, we then want to determine what kind of pathfinder we are. Cursive equals false. I don't think the path next knows how to use the layer system, by the way. Oh yeah, it does. It has no clue. Yeah. So we're going to force it to use the current system, which means we then want to path entire, and we want to call stack.pull. Does it even use the starting node here? It does. It doesn't give any craps though about it, so whatever node you pass in there pretty much could be null. So what we want to do is we want to copy this entire part here. We want to make a new thing called public void continue path entire. And this one is only going to need these two methods here. I mean, these two parameters. It would continue path entire, and then would list and count. Because we don't care about the starting node. And this lets us call continue path entire instead of calling this one right here. That way I only need the list. And then there's a count. Where does the count come from? Blocks per layer. And then I'm going to move this up here. Because I don't need the starting node, of course, in this. And I'm going to grab this and toss it down at the bottom, because this is where our main edit loop is going to be. And then also on top of this, I'm going to switch this to the debugger. Debug printer.log. And then we're going to do a few things with this. We're going to go and make this a little easier to read. So I'm going to go edits. And then we want locations, and then we want stack. Okay. So we're going to do 2 more. And we want path will be the next one. Path locations. And this is going to be stack. So we want to know how much we have in the stack. Dot size. I probably should do delta path, so how many locations we've pathed that turn and how many stack entries we added to the stack, because that'll give us more details. But this should work. And we'll change this real quick. So go call to continue path finding. Okay, that should work. Yeah, that'll do pretty well, because it means we can test this a little easier, and then do a few things here. And I step away for like 1 second because somebody's telling me my food's burning. Okay, false alarm on that. Apparently the food was not burning. Just people can't understand the difference between burning and not burning. Okay, so this looks good so far. Path location. Actually, we could just pass the start node in here. I don't know why we're using a new one. Looking good so far. This will prevent it from trying to reuse that starting node. Luckily, it wasn't doing anything with that, so that it was definitely not the problem. We'll go ahead and launch this back up. Oh, it's gonna. Oh no, it's fine right there. Okay. Oh wait, we aren't calling our method here, so we want to call get effective blocks, and then we want to provide a list here. Is this storing effective blocks? Guess we can just do this. New array list. And then we want to pass an I. Why is that? I know why it's void. Okay, so we want to do that, then pass in. Okay, I'm gonna kill Minecraft off so I can actually fix that. Why is that a collection? That's a collection because that's a collection. Now that's a collection for I don't even want to know what reasons. So we'll undo that. We're going to just cast this real quick. I don't know why it is, because almost all the blasts use that, but there's probably some legitimate reason for it. So to get our affected blocks, we'll pass it in, we'll pass in what layer it is, and it should run a little better now. Not by a huge amount, we're not going to notice the significance here. But if we fix our debugger, which is one of the things we did do, we should start to get a picture of what's going on each loop, and then through that we can figure out why all suddenly it stopped pathing certain things. And let's add a next node to this. That looks good, good. I mean, I'm not seeing any major flaws in here. That's the sad part about this. We're having all these issues, but when you sit here and look through the code and it goes, well, yeah, it should work. There shouldn't be any problems with it. So we got a breadth first pathfinder that should be doing its job pretty well. It shouldn't have any issues with trying to repath certain nodes or doing duplications. And let's close these down real quick and go find my test package here. So what I want to do is I want to call blast dot get affected blocks and then layer. So we want to do list I world edit. Edits equals new array list. Then we're going to pass in edits, and we're going to do that. And then what I should see is after I call that is edits dot, or I should do it this way. Search equals 1 and then edits dot size. So we should only have one block on the first run. And then we want to see if we can get access to the stack as well, because our stack should contain 6 blocks. Blast.stack. Oh, stack is not public. That's probably going to backfire on me. We want to make sure the stack has so many items. So we want to know, is the Pathfinder running properly every single tick it runs? Anyways, fire this real quick. Oh, I just shot myself with that missile. And it's doing the same thing it's doing previously. Here we go. Our Pathfinder is actually running as needed. We're getting L0 every single time on this. Stack 66. Okay, so we want to go into the first time we start seeing stuff. L0, so it ran only once. L0, so it's running only once. Yeah, we're starting to see a clear picture here. We're running the current count only once for some reason. I might have messed my debug up, but we'll take a look at it real quick. Stack is not empty, should not exit, and current count is less than count. That's set to 1,000, so what's going on here? It's acting like the current count is 0, I think. Okay. Let me take a look at... Yeah, we're going to hit debug on that line because I want to see if it's running all its loops. Okay. Current counts 1. We go through... Yeah, a lot of this. I need to separate out this code from the main thing, that way it's a little easier to debug. If I go really quickly and find the bottom of that and put a line there. Okay, what was that? Current count equals 1, count equals 1,000. It just exited out of that loop for some reason. Should exit is true. Why should exit equal true? Should kill action. So something told it to kill. Oh, that should be a not symbol. We found our bug. Yeah, I'm gonna have to restart the fix to see that change. But it looks like what was happening is the reason why we're only getting so many runs here is the layer system doesn't actually have a definitive understanding that you've run the number of blocks you should have run. So I probably should change it from a layer system to a continue action system and then kind of hide the layered approach to it. Because what's going on is that it thinks it's completed all of its layers, but it has not. It actually is nowhere close to completed all its layers because there was a bug on the code. Let's run this simple test real quick. It just ran all 120 even though it wasn't supposed to. Effective blocks 1. No. I mean, it makes sense, I guess. What we actually want to call on this one is continue pathing. And then we'll do edits. And we only want to run one edit at a time. And then this actually surprisingly needs to go down here. No, that won't work. Crap. We need to call path entire at least once. So first call needs to be this. It has to be our starting node. This would be new block pause, and this would be 0, 30, 0. Okay, and did it not launch Minecraft? Or did it crash mid-launch? It just exited on us for no reason. There's no crash in there. Run, debug, ICBM client. While that's running, I'm going to hit run test on this. Even though this will actually get caught in test all. Oh, you know why it didn't work is because the test all the things probably crashed. Yeah, I won't let us run unless that runs. Well, derp. Because watch, it'll crash out here. Yep, there it goes. What's dumb about it is trying to scroll down here to actually get what we're looking for. Should path to... Oh, yeah. Null point exception because the center didn't get set. I need to fix that center check problem. So I'm going to move center to blast here. 'Cause every blast should know where it's at, location-wise. And then all I need to do is I need to figure out where X is set. Oh, well, that's going to tell me everywhere it's used. Okay, so set location, then what I want to do is I want to go, okay, center equals new location, world X, Y, Z. That way there's no chance of center going null any single time. And then we don't have to reset it every single time we want to do something here. Let me make sure that there's nothing else using this. Okay, find usage. Thank you. Okay, it's only been written in one spot, so that's good. That should fix our problem. Yeah, we're having still a couple issues. How do you find 7 edits? That actually surprisingly makes sense. Okay, because you would have one center block and you have 6 blocks around it, so 7 is actually a wrong spot there. I was thinking it was only going to edit once the first time. This tells you how well I understand my own code sometimes. This is why I always say I need to document better, because I have no notes on this. At least no legible notes. I have notebooks, of course, but they're not useful. Okay, you have 8 objects in the stack. How do you have 8 objects in the stack? 1, 2, 3, 4, 5, 6. 7 edits, 6 in the stack. Yeah, you're telling me there's an insertion error here. Check values. Test blast. Oh, we're having a problem up here. How are you getting 8 edits? Expected 7, actual. We can see down here we only have 7 edits here. Yet it found 8. Okay, so check blast, pops the blast off, then checks value size. And then what it's looking for is a number of edits. It's finding 8, even though the fact is the list clearly says down here 7. So I don't know where it's finding an extra here. Unless this is not what it's actually going on. Hold on, we're gonna debug this, I guess. We're gonna make another method here. So private final void reset. We're gonna need the world though. World. Grab this. And then right before check blast runs, I'm gonna reset the world every single time. So reset and then world. And then that means down in my other check right here, I can call reset as well, which will save me a little bit of time there. Let's run this again. We're going to debug through it real quick to see what it's doing. So we're going to go check blast. It's going to reset, which is going to give us okay. We're going to pop the blast. It's going to create the blast, set the location, it's going to set the yield, edit list. It's going to get affected blocks. Just a note, the recursive stuff is never used because it crashes all the time. So we got our first node. Okay, continue editing. By the way, check the console. Yeah, it's not, the debug printer is not printing anything off. Yeah, this looks fine. Go hit play. It's probably still going to fail. We still see down here it says, okay, we have 7 edits, but it's like, here, I found 8. And it's like, how did you find 8? What did you break? Why didn't I get a oh yeah, you don't get a debug line on initialization of values. No, we're not getting anything there because it's failing to insert right here. Which, let's put a debug line there then. Now let's hit reload while we're... Oh, we're not on hit reload, okay. There we go, debug line. It's got 8 edits. I'm not sure if any of these are duplications because my eyes are having trouble kind of scanning over them. But it doesn't look like it. Because there's our center block. There's the block that's below us. It should have not been the first thing well, I guess it would have been. There's a block above us. That's actually not the block above us. That's a diagonal block. How did you get a diagonal block? I think it's the one that shouldn't be in there. And then we get another one down here, which is a diagonal block as well. It's very strange. We're missing, I think, a couple blocks in here too. There's another diagonal block. So if our size is 1, we should have only got 7 back. We're getting 8 back. We got 1 extra, but a lot of these are diagonal blocks, which doesn't make any sense. Oh no, my brain's failing. These aren't diagonal blocks. That's the block to the north. That's, I believe, east. That one shouldn't be there though. Same with that one. That one is a diagonal block, and so is this one. We're having a problem where it's not pathing correctly. Oh, crud. Hit play. Now, Path Entire seems to have gotten the correct entries. It thinks there's 7 in here, which is what we should have. So it's not that this is pathing incorrectly, it's grabbing extra blocks it shouldn't be grabbing. It's trying to grab everything within size 1. Which those would be within distance 1. Let me check the set location and see if it's running properly. Yeah, let's do this real quick. Math.floor plus 0.5. There might be a rounding problem here. Oh, we have video time. 54. Man, I haven't really accomplished anything today either. We're debugging code that's just been here for a while, trying to make it work better, and getting no closer to the objective of getting things to work nicer and then getting stuff updated. So that should force our center location to be wherever we want it to pretty much be the center of the block. I'm going to change the name of this. block center. Exclude. It's pretty much the only thing it's actually used for is to make sure that the center of the blast is correct. I have a feeling the distance check is maybe skewing a little bit, so let's go find the distance check. That should be should path. This is probably correct because I mean those diagonals are within one. But if we're doing a 1 radius, we should be getting more than 8 instead of just 7. The reason behind this, let me get paint out real quick. Okay, so if we're pathing from a center point right here, that's our starting point. It's supposed to path out to the sides, up and down, and if my drawing skills were anything good, this would not be as bad. So it's going to do these directions first, but then these 4 corners are within a radius of 1, because you're going to be, well, they're actually not within a radius of 1. There should be like 1.5 between these. Yeah, so these are the corners which are showing up in the Pathfinder that it should be showing up. Our first entry should be that, and then our next ones should be these. But somehow we're getting the red corners, which we shouldn't be getting. And of course, this is a 3-dimensionally, by the way. Even though I'm doing a 2-dimensional image, this would be in all directions. So if we're getting 1 corner, we should get all the corners. That means there should be 4 additional values in the list than our original, because we have the center, which is 1, and then each of the sides, which there's 6 sides to a cube, would give us 7, and then you add 4 more onto that, which would give us 11. I think. No, there's more than 4. There's 8. I knew my math was off somewhere. So if you get should be a 3x3, which would be 27 actually. 7 plus. I'm having like a rough time with math these last couple days. So 27 if it was a 3x3x3, which is what it should end up as. But the distance between here and here should be like 1.5, so we shouldn't have got our check. So there is a problem with the distance check. So what we want to do, and we're using an integer value for size, which is probably the problem. So we're going to switch this to a double. And then I'm going to move this to the bottom, because I want these checks to run first. And then the next check I'm going to run additionally here is if edit.distance, actually we're going to do it this way, so it'll be, oh, I'm going to need the blast. Check value is called here. Let's move this code up here, put this here. So we get rid of pop blast here. That's just an extra thing that we don't need right now. And then we want to be able to pass the blast back in here. That way I can run a distance check. So to be blast.center or block center dot distance to edit. Edit is less than equal to blast.size. That's what I want to kind of check to make sure that we actually are here. And what we want to do is actually, if it's greater than size, we want to do a fail here. Edit is outside size of blast. And then we can just do really quickly, we can put the edit here. And then what we want to do is we're going to kind of catch the distance so that way we know what's going on here. And we know how big it is. So, and then do this, so it'd be D is greater than blast.size. So our check's still going to fail, but maybe it'll fail up here, so it'll give us a better indication what's going on. Yep, edit is outside, so we have a size check issue. So we're 1.65 outside, and it should be 1 because our size is 1. So that indicates what's wrong with our system. And it's a good thing we have a check here, so we're going to use distance check, edit checks. This is going to be blocks found. Cool. Now we just got to figure out exactly what's wrong with this. I have a thought process. I'm trying to think of what exact, because I think what's going on is this edit might not be perfectly centered, so I'm going to do this real quick. Xi edit dot yi and then edit dot zi and then plus 0.5. What? We didn't change anything, and it just started working all of a sudden. Okay. I am confused. Because this was failing repeatedly, and we didn't change a single line, and all of a sudden, boom, it's fine. I would say that's mod development, but that shouldn't happen. So I'm going to rebuild everything real quick to make sure that we didn't just get a fluke of luck. Huh. Since that's done building, I guess we can go ahead and launch ICVM and test it. And we're past our hour mark, but we're almost done. And hopefully I can go back to testing what I want to be testing, which is testing some of the Sentry guns and then getting the nuke ready. And this is why it takes so long to get mod development done, is we have to do this, and I've put maybe 10-12 hours into debugging this issue. Let's go ahead and run this again. Make sure it doesn't go to fail on us randomly. It's running, whatever. Debug Minecraft. For some fluke reason, it is functioning as it should. The least good thing is we now have distance checks to ensure the distance is proper. We now have edit checks. We have duplication checks. So we added more to this, so it's not hasn't been a waste of those 12 hours. as our tests are now better, and the better the tests get, the less likely it is when we release a mod that there is a bug in the production. Because the last thing I want to do is actually release mods that are broken, especially with the organization name I have. I'm going to regret naming my organization Build Broken Modding for like the rest of my life. Even though I love the name, I'm always going to have to deal with the fact that every time we release something broken, there's going to be that joke. Well, it's built broken. It's not at all what the company's name means. There's actually, I do plan to do a video here later that actually does explain why it is called Built Broken. It has a lot to do with kind of our ideology. I mean, originally the name started off as a joke, but I kind of pulled off like a Marwin type thing. So in Marwin, there's a question that if somebody's making fun of you, what do you do? And the options they give you is you can fight back, you can ridicule the other person, or you can make a story that makes the name sound legendary. I went with the story that makes the name sound legendary part. So Built Broken kind of has to do with the name, but at the same time it doesn't. Because we've got an ideology that we seek out broken things and fix them, kind of pretty much. It's one of the reasons why we have it build it, break it, reanimate it is our motto for the organization. It's going to be the same motto for my game studio too, because both are going to share the same name. So you'll have Built Broken Modding and Gaming, which will be the modding and community organization, and then you'll have the studio, which will be Built Broken Studios. We're still not sure if we're going to call the publishing company Built Broken Publishing, but we haven't got to that point yet. It's working! Yes. That's what it's supposed to do. That destruction, yes. I might want to nerf the radius on this. I'm so happy though. I need to add a chemical gas effect to this because it looks so much cooler if you see this like deathly looking gas just spread out in all directions. Oh. This is one of the reasons I love working on ICBM. I don't really love the idea of destruction, mayhem, and stuff like that. I'm actually slightly against it, but I love things like this, where you build something and it works. And it does exactly what it's supposed to do, even if the result is slightly harmful. It's a cool little challenge. But man, that's nice. So we should be able to get back to testing, so I'm going to call this the end of this video, and I'll be back.